YouTubers, welcome back again. This video is going to go in a little bit more in depth into how the electrons move about the system. So forget our whiteboard going once again, and let's try to get a little bit of understanding on that. So electrons orbits and the nucleus, which is in the atom nucleus, and they float around the outer edge in rings. Depends on the element, depends on how many shells, or rings I should say. And these electrons. Electrons are negatively charged. So when we're talking about electronics, we're talking about conventional flow. So, positive to negative. We say that the electron or current flow, which is amps or electron movement, moves from positive to negative. That's conventional flow. However, true current flow, the way your amps or your current moves throughout your system, is actually from negative to positive, because the electron is negatively charged, is attracted to the positive. That's how your old Radiation King TV works. You know, the old tube, cathode ray tube TVs? The electrons are fired to the screen. The electrons are negatively charged. So, an element like steel or copper or something like that has very few electrons in the outer shell. Anything that has up to 3 is a good conductor to electricity and will move freely because it's less resistance, I guess, if you will. I'm not sure how that bit works. But anything that has 5 electrons in the outer shell, like glass or wood, there's no current flow. It can't move around freely. Carbon and silicon has 4 in the outer shell, where they're completely different kind of materials. Carbon is more of an insulator, silicon is conductive and heated up. So, as you can tell, we're getting a bit into the physics side. So, how does it actually move? Well, we've got one atom here, one atom here, and here. So once again, you got the positive side here and the negative side here. The electron that is centered around the outside. When one electron jumps orbit to the next one, this one here follows, leaves a hole for this one to follow, makes a hole, and so on and so forth. So that's how electrons move. What you're actually seeing is the holes, the movement of holes goes from positive to negative, and that's conventional current flow. So electrons is pretty much the amps. How many of these electrons are moving per second? The more amps, the more electrons move, meaning you need a bigger wire, because the wire needs to be so big so all these electrons can move. And if your wire is small, well, we're not going to have much wire for the electrons to do the movement, which is going to restrict them, and that's where you get your heat. So you need the wire to allow for the amount of electrons to move. So a bit more of the physics side, way out of depth for off-grid solar, but to me that's interesting to understand how it works, because when you understand this, you get to understand your wiring on your system. The electrons are physically moving, they need to move, they need the wire to do it, and if it's restricted, just not going to get through, you'll burn out your wire. So it's physical. Anyway, this might not answer any questions, but it was just fun to do these kinds of videos. So any comments, any questions, please drop in the comments. Please subscribe and give me something on the way of feedback so I know I'm putting out videos you like. Thank you very much. See you next time around.